Bismillahirrahmanirrahim. Uh, Today I am going to start discussing the functions, uh, the core idea of the course. Uh, First, we will discuss some basic ideas about function like limits and continuity, and add a new dimension to our exploration of limits and continuity of a function at a given point and over an interval. This may sound clear.
Yes, sir.
Okay. Uh, so let me begin with uh, with the concept of limits, which we already know about. And you know a lot of things about function, the definition and different kind of functions, their graphs, etc., etc.
वाईफाई कनेक्ट कर दो
Uh,
क्यों
am I anything wrong?
सर सॉरी
All right. So we step onto the idea of limit that you also are aware of, but we will still go through it and add another dimension to the determination of limit of a function. Hope you remember that f is defined over a deleted neighborhood. That means from c minus delta to c plus delta. Every point except for example the set of c where we are seeking limit. The function is set to tend to a limit L as x tends to the number c if for every epsilon positive there exists positive delta such that if x belongs to the deleted neighborhood indicated by x minus c greater than 0, the radius of the neighborhood defined by delta, then the images will be in a small neighborhood of the limit L. If the limit exists, we write this as this conventionally. This sentence usually is written as this: fx minus L is less than epsilon whenever x is in the deleted neighborhood of C. And this part, fx minus L less than epsilon, in fact means all image values are lying between L minus epsilon and L plus epsilon. When we have the situation that as x approaches c, the image values goes to infinity. हम elementary level पर कभी-कभी ये भी कहते हैं कि if limit is infinity or minus infinity, the limit does not exist, but we are considering these as limits here. So in our formal language, this will be expressed that for every number g positive as large as you think, there exists a delta such that all image values are greater than g when x is in the deleted neighborhood of C. In our formal language, this expresses the fact that limit as x equal to C of the function f is infinity. If it is infinity, then you can find a large number g positive such that all function values are less than minus of large number g when x belongs to the deleted neighborhood of C. Then we many a times talk about limit x approaches infinity. If the function has a limit when x approaches infinity to be some finite number L, then we say that for every epsilon positive, there exists a number k large such that fx minus L is less than epsilon. That means image values are within the neighborhood of L for every x which is very, very large. Similarly, when x approaches minus infinity, we can write a similar sentence, but with negative large number. When x is very, very large but negative, the function values are found in the neighborhood of finite point L. As x approaches infinity, fx is infinity. Then for every large number g, there exists k greater than 0 such that fx exceeds the large number you consider as g when x is also large and the other large number that is used for domain values when the x value is greater than the large number you think that means goes to infinity, then the image values are also very large, greater than the largest number that you think. We have talked about in earlier cases left-hand limit and right-hand limit. If you consider the left-hand limit of the function to be L, then image values are in the neighborhood of L whenever x is in the left-hand side part of the neighborhood of C, leaving out C. Similarly, right-hand limit, and you consider that image values are in the neighborhood of L whenever x values are on the right in the right side of the neighborhood of C, defined by delta. You have seen these kind of examples where a given function is defined using this relation when x is not equal to 0, is not equal to 4, but function has value 0 when x is equal to 4. The function is defined for all real numbers. At x is equal to 4, it is having value 0. Otherwise, function values have to be calculated using this formula. And we have to find the limit as x approaches 4. And you are familiar with this, I hope you are familiar with this process. You evaluate left-hand limit. That means 4 minus delta. So delta approaches 0, x replaced by 4 minus delta in this function, both in the numerator as well as in the denominator. In the numerator, 4 cancels out and negative delta becomes positive delta due to absolute value. In the denominator, 4 cancels out and we are left with minus delta. Before delta becomes very, very, very small, or this number is already minus 1, so left-hand limit is minus 1. Similarly, when we evaluate the right-hand limit, we use x is equal to 4 plus delta, that is on the right-hand side of the neighborhood of 4. When 4 cancel out in the numerator without changing of sign, denominator is 4 plus delta minus 4, and the number before it goes, delta goes to very small numbers, it is 1, so limit remains 1. So left-hand side limit and right-hand limit are not equal to 1, so we say that the function limit as x approaches 4 does not exist. Remember that for x greater than 4, mod x plus 4 can be written as x minus 4. And for less than 4, mod x minus 4 can be written as minus x plus 4. And instead of using 4 minus delta and 4 plus delta, you can use these alternate definition of the function. That when x is greater than 4, you use this. When x is less than 4, you use the other minus x plus 4 and evaluate the limit, and you have similar results. Let us consider an example which is a typical example of a more complicated function, and we have to find this limit x approaches 0 from the right-hand side. Now, from the right-hand side means x is positive, and x goes to 0. This number goes to minus of infinity, and that means e power minus infinity, that is 1 upon e power infinity, which is 1 upon infinity. That means this part goes to 0 as x approaches 0 from the right-hand side. So the limit is 1. All this working is shown here. But if we use the definition of limit in terms of epsilon and delta, we write fx minus L less than epsilon when x minus 0. 0 is the point where we are seeking limit. And it is right side, so x belongs to 0 to 0 plus delta. and we work out fx minus L. So fx is this, minus L means minus 1. Do some algebra, take the LCM, simplify, and it becomes this. You can rearrange it into this form, which can ultimately be written as this for x positive. Now, we can use 1 upon 1 plus e power 1 upon x as the epsilon, because this whole thing has reduced to this. So this taken less than epsilon means 1 plus e power 1 upon x is greater than 1 upon epsilon, and e power 1 upon x, 1 upon epsilon minus 1, which takes you to this form. Apply ln on both sides, and we see that 1 upon x is greater than this, and take reciprocal, and x is less than this. So this expression ln 1 upon epsilon minus 1 becomes delta. So the formal language, fx minus L is less than epsilon whenever x is less than this delta. And you can go for calculation of epsilon, choosing epsilon and calculating delta with epsilon is equal to 0.01. 1 upon epsilon minus 1 becomes 99, and log of 99 raised to power minus 1, which we have taken as delta, is 0.21. You decrease epsilon, and the delta will decrease. So this is a demonstration of epsilon delta use of proving that this function has limit 1. Now, what about limit of x into sine of 1 upon x? We directly go to the epsilon delta expression. So if this limit is 0, we consider fx minus L less than epsilon, and then further explore this. So mod separated product may it is less than or equal to x mod, because sine, whatever value of input to sine is, the sine function taken in absolute cannot exceed 1. So this remains less than or equal to 1. So mod x remains less than or equal to epsilon, and epsilon and delta in this case are same, because this mod x simply means x minus 0. So whenever fx minus 0 is less than epsilon, x minus 0 is less than delta, which is same as epsilon. So in this example, epsilon and delta are same. And with this, this also proves that whenever epsilon chosen, we can choose delta to satisfy that epsilon delta definition of limit. And it is proved that this function has limit 0. Now, if the limit exists, we can prove that it must be unique. We cannot have multiple limits of a function at a given point. Then if you have a function whose limit is L1 when x approaches A, and another function whose limit is L2 as x approaches A, we can prove these results. And I leave this for ये PTY नहीं है, PYT, prove PIY, sorry. Prove it yourself. And you can find these proofs in elementary calculus books as well as the book that we are currently considering. I've considered some more examples. Evaluate limit of x squared minus 4 upon x minus 2. The procedure of finding limit is described in terms of 2 minus delta and 2 plus delta for left-hand side and for right-hand side. And from the two sides, the limit does not come out to be same. Let me see, x squared, x replaced by 2 minus delta, which makes 4 minus 2 delta plus delta squared. 4 cancels out in the numerator, and minus delta taken common, and 2 minus delta, delta approaches 0 gives you 2. Whereas 2 x raised to power 4, and then it will be 2 plus delta raised to power 2, that means 4 plus 2 delta plus delta square, and here delta taken common. ये मैंने यहाँ गलत लिखा हुआ है, नहीं सही तो लिखा हुआ है, यहाँ गलत लिखा हुआ है, because left hand limit and right hand limit are both 2, so this has to be 2. Note that this function is not defined x equals 2, that is why in the definition we consider definition of limit, हम 2 का जो neighborhood है वो derivative consider करते हैं. Then epsilon delta demonstration, and we find that numerator, when we simplify this, तो मैंने गलती की भी है, ये लिमिट 4 इस्तेमाल की हुई है जबकि लिमिट 2 है, तो यहाँ पे 2 आना चाहिए, जिसकी वजह से यहाँ थोड़ी सी तब्दीली आएगी, कुछ तब्दीली की वजह से यहाँ कुछ गड़बड़ होगी. Anyways, x minus 2 can be extracted from this. Let me consider this on the whiteboard. We check 2 and 2, so the limit is 2. So this should be 2. Even if this is not written correctly, but this step is correct. यहाँ पे अगर 2 नहीं, not correct. Go to the whiteboard, or you can do that yourself. We were working x squared minus 4 upon x minus 2 minus 2 mod less than epsilon. So that becomes x squared minus 4 minus 2x plus 4 divided by x minus 2 mod less than epsilon. In fact, 4 and minus 4 cancel out, and that gives you x squared minus 2x upon x minus 2 mod less than epsilon, which ultimately gives you mod x is less than epsilon. Is it so? X common, x minus 2 cancels. So there is something wrong. Yes, I have minus 2x plus 4, 4 cancels. Because this should be like this, when 0 less than x minus 2 less than delta. I should get out of this I should get this thing. If I take it from here and write it as x minus 2 upon x squared minus 2x, which will be less than 1 upon epsilon. And x minus 2 is less than 1 upon epsilon into x squared minus 2x. Now, when x is very, very close to 0, this number is going to be small. And not x is very, very close to 2, 4 minus 4, and it is small. We can define this as can define this as delta. Uh, Now epsilon is small, but of course this, when x is very, very close to 2, is very, very small. That doesn't seem to be very logical, but I think that is it. That should be it. Uh, ah,
सर आप -4 से करेंगे तो आपके पास आएगा
अरे रुक जाओ,
x में।
रुक जाओ, रुक जाओ, रुक जाओ। मैंने कुछ गड़बड़ की है, मैंने कुछ गड़बड़ की है। लेट मी वाइप इट आउट। X square minus 4 upon x minus 2 is the function. The limit is 2. This is equal to x square minus 4 minus 2x plus 4 x minus 2. I'm not in the right frame of mind. I suppose I am doing something seriously wrong. -4 से क्यों करूँगा मैं? 4 is not the limit. The limit of the function is 2. I'll recheck it and come back to you. क्या गड़बड़ है इसके अंदर? Usually it is pretty easily done. Signal function limit x approaches 0 of mod x upon x and 0 minus delta, and we get -1 limit mod x upon x from right side 0 plus delta, and we get limit 1. Limit does not exist. And if I use that epsilon delta approach here, then in the first case, mod x upon x minus, the limit is -1. So this becomes when x is less than 0, mod x is minus of x. So -1 plus 1. And we have epsilon positive, and epsilon and delta are same in this case. Same is the case with this. और ऐसी एग्जाम्पल्स हैं जिसमें मैंने एप्सिलॉन डेल्टा डिमॉन्स्ट्रेट नहीं किया, बट मोर वी डू इट मोर वी बिकम कंफर्टेबल. इन दिस केस द लेफ्ट हैंड लिमिट के लिए मॉड एक्स -x लिया गया है, मॉड एक्स -x लिया गया है, और लिमिट इवेल्युएट की गई है 1/6. एंड फॉर x टू द राइट ऑफ 0 मॉड x ही लिया गया है, and then simplify and you get the limit 2. Limit does not exist. These are examples where limit does not exist. Limit for this expression, and it is no trouble, and Left hand limit comes out to be 1 by 32. And I hope you can evaluate right hand limit by replacing. Whenever we evaluate limit x approaches 1 from left side, we replace x by 1 minus delta and evaluate the limit. And when we consider right side, जो कि मैंने नहीं किया हुआ, x approaches 1 from right side, we replace x by 1 plus delta and go for calculation. And you will have a different limit you come when you work out for right hand side. Usual cases of limits, but मैं इनमें से कुछ ये ज़रा आप खुद देख लीजिएगा किस तरह cos 2x को इसमें कन्वर्ट किया गया. उसके बाद दो लिमिट्स बना दी गई, एक 1 माइनस कॉस होल स्क्वायर अपॉन एक्स स्क्वायर और एक लिमिट sin x upon x whole square, and the limit comes out to -1. Look at this. X approaches 0. Presence of this x is interesting. When x approaches 0, this part, e power infinity, 1 upon infinity is 0. So the denominator goes to 1, whereas numerator goes to 0, and the limit is 0. Left hand side, right hand side approaches are similarly dealt with, and we get same results. Now here we have to show that this limit does not exist. Worked out from left hand side and see what is done. 0 minus delta replaced for x, and this expression converted to this form by multiplying both the numerator and the denominator by e power 1 upon delta. Then here, instead of using that logic when delta is 0 or goes to 0, this goes to infinity, and e raised to power infinity is infinity. So numerator is sort of minus infinity, denominator is sort of plus infinity. That doesn't give us a limit, and we may tend to use L'Hopital rule, but another thing is done here. The expansion of e power x, I hope you people are aware of that expansion. What's that expansion? E power x is equal to 1 plus x square upon 2 factorial plus x cube upon 3 factorial, and so on. Now, if you use this expansion for e power 1 plus 1 upon delta, then we get this thing. Similarly, in the denominator, we have written the expansion. In the numerator, expansion में जो आने वाला 1 जो है वो इस 1 से cancel हो जाता है, whereas in the denominator it adds up. Now it becomes 0 plus negative 1 upon delta square, 1 upon delta cube. This becomes a large number, so I have written that 0 minus capital T, in the denominator 2 plus capital T, and I consider T approaching infinity. And then cancelling out g from both numerator and denominator, this reduces to -1 upon 1 plus 2 upon g. And as g goes to infinity, this becomes 0, and we get limit -1. And when we work out from right hand side, we will have this thing e power positive 1 upon delta, e power positive 1 upon delta, expansions written, and 1 cancels in the denominator, 1 adds in the denominator to become 2, so g upon 2 plus g, and that goes to 1. So we have not used that L'Hopital rule. Instead, we have worked with the expansion of e power x to show that in the numerator we have large negative numbers, in the denominator 2 plus large positive numbers that lead to the limit -1. And for right hand side, this leads to the limit 1. Left hand limit are not equal to right hand limit. This is similarly done, and you can follow that. The same logic is used here. Yes, as I promised to add some new dimension, and that new dimension in the process of evaluating limits is the sequential approach. In the examples above, I have just reviewed the process of finding limit using left hand side approach and the right hand side approach. If you are seeking limit x approaches a, so I have worked with a minus delta for left hand limit and a plus delta for the right hand limit. Sequential approach, in fact, allows us to extend our ability of approaches towards the point where we are seeking limit. This is the usual thing. Now, if I consider a sequence of numbers in which none of the term equal to c, where I am seeking limit of the function, but our assumed sequence converges to c. Remember, it is possible, we have studied sequences, that none of the term of the sequence is equal to the limit, but the sequence converges to the limit, that particular limit. So for every epsilon greater than 0, there exists a positive integer such that terms of the sequence are within a small neighborhood of the point C where the sequence is converging. All the terms of the sequence are in the neighborhood of C after first few terms. Now, if I replace x by xn in the given function, limit xn approaches C should be equal to L. So our new expression is now fxn minus L less than epsilon for every n greater than or equal to this, because for a sequence that we considered in the domain that converges to C, we have in fact formed a sequence in the images, and that sequence converges to L. So we can convert the whole discussion of x approaching C, fx goes to L, into this language. That domain points, instead of being considered left-hand side or right-hand side, we consider a sequence in the domain which converges to C and evaluate the function or images at the terms of the sequence that converges to C. So there is a sequence in the domain and there is a sequence in the range. So as the sequence in the domain goes to C, the sequence in the image goes to L, if this limit exists. So this is a new expression of finding out, new tool of finding out limit that we are going to consider in some examples pretty soon. So this is the thing that we have added to our idea of evaluating limit. Let me introduce the concept.
रिपीट कर सकते हैं ये वाला जो आपने
बिल्कुल
भी
कर सकता हूँ, बल्कि एग्जाम्पल अभी हम डिस्कस करेंगे और वाज़ेह हो जाएगा। देखो बात ये है कि let me go to the whiteboard. We talk about neighborhoods of C, and we are seeking what? Limit x approaches C of the function equal to L. मैंने इस ड्राइंग में फंक्शन को डिफाइन दिखाया है x इक्वल टू c, कोई ज़रूरी नहीं है कि यहाँ पे डिफाइन हो ना हो, इसके नेबरहुड में डिफाइन होगा. So we have in our usual treatment, we consider neighborhood of C and we consider the neighborhood of L. So this is L minus epsilon, L plus epsilon, और हम कहते हैं क्या कि fx माइनस एल इज लेस देन एप्सिलॉन, यानी इमेजेस जो हैं वो इस इंटरवल में हैं जब जब प्री इमेजेस जो हैं वो इस इंटरवल में हैं। ठीक है, सी माइनस डेल्टा और सी प्लस डेल्टा को फिर हमने लेफ्ट और राइट लिमिट निकालने के लिए इस्तेमाल की। What we are doing now is that we are considering here points within this neighborhood that are members of some sequence. Okay, and that sequence converges to C. When I consider images of these points, there will be corresponding points representing function values at xn, where all xn belong to I, and I is this. So there एक sequence मैंने pre images की consider की that converges to C, and it is not necessary that xn is equal to C, just like we consider deleted neighborhood. So एक sequence मैंने pre images की consider की जिसको मैंने कहा and this can always be done. This can always be done. जो sequence की terms हैं उनकी images ली, तो उनकी images लेने से एक sequences बनी जो के images की sequence है. Now if x approaches C, function values goes to L, then I can instead write down limit n approaches infinity for image sequence. Now this is a sequence of images. हम कह रहे हैं कि that if the sequence is the domain और pre images की sequence C पे जा रही है तो फिर images की sequence जो है वो L पे जाएगी, and these two are in fact equivalent. When I write down this kind of sentence, then I will write down image sequence term minus L will be less than epsilon for all n greater than some number m, because now this is a sequence, or sequence convergence to L requires that only first few terms of this sequence are outside this interval, all the rest are inside. So that is the idea. And how many sequences we can make in the domain that has limit C, that we will pretty soon see in examples. So I hope you are a bit comfortable, not necessarily completely comfortable, because whenever we are exposed to a new idea, it takes a little time to absorb. So don't be परेशान कि फौरी तौर पर तुम्हें समझ में नहीं आ रहा. At the same time, let me introduce the Cauchy criterion for existence of limit. Cauchy criterion कहता है कि if x approaches C, fx goes to L. That means for every epsilon positive, there exists a neighborhood of C, a small, how small, as small as you can think of. In that neighborhood, if you take any two x values, any pre-images, then their images will be very, very close. This expression means when x is very, very close, fx is very, very close. Here what we are saying that in a small neighborhood of C, if you choose any two x values, then the images at those x values will be very, very close to each other. So this is an alternate expression of existence of limit, and when we write down this expression, we call it Cauchy criterion. Okay, what if x approaches to infinity? and fx goes to a finite number, that means when x is very, very large, so choose two large values of x. Then the images for the two x values, which are very, very large, these images will be very, very close. Only then this limit, a function f goes to this limit L. अब देखो कि इस एक्सप्रेशन में भी और इस एक्सप्रेशन में भी लिमिट L का जिक्र नहीं, क्या जिक्र है कि images will be very, very close. And this is exactly what happens if you look at that drawing. When x is very, very close to C, y values are very, very close to L. L is the height of this point. This point, whether function is defined at this point or not. This point has coordinates C, L. Now fx is equal to L or not, but this point is having coordinate C, L. So ये जो हमारा सेंटेंस है ये क्या कहता है कि when x is very, very close to C, then fx is very, very close to L. The images are very, very close to L. So expressing the same thing, if you consider some x1 and x2 very, very close to C, then the images are very, very close to C. So this point and this point has coordinates. For example, this point corresponds to x2, so x2, fx2. This point here is x1, fx1. So fx1, this height, and fx2, this height, they are very, very close to each other. They are not very different, and that is expressed in the Cauchy criterion. fx1 और fx2 के दरमियान जो distance है, that is small for each x1, x2 belonging to the neighborhood of C of size delta. You take delta very, very small, x1 and x2 are very, very close to each other. In that case, the corresponding images are very close to each other. इस alternate way of defining limits में limit L का कोई जिक्र ही नहीं, पॉइंट C का जिक्र इसलिए नहीं है कि डिलीटेड नेबरहुड है, तो इस पॉइंट के कोऑर्डिनेट्स CL इन दोनों का कोई जिक्र नहीं है, and when we express the idea of limit in this way, we call it Cauchy criterion. Let us see this example. Limit 1 upon x, sine of 1 upon x. हम कह रहे हैं कि this does not exist, हमने prove करना है. Now the point is that if I work out this limit 1 upon 0 separately, अगर 1 upon x separately करूँ तो वो infinity जा रहा है, और 1 upon 0 साइन को अलग कर दूँ तो ये sign of very large numbers, and these values will be between -1 and 1. But I'm not able to make any conclusion. It feels like this limit does not exist, but let us prove that using sequential approach. And let us define the terms of the sequence by this. Here is an example where we use sequential approach for discussion of existence or non-existence of limits, and we use this sequence 2 upon 4n plus 1 pi. As n approaches infinity, you can see that this easily goes to 0. So what will be the image? xn replaced by 2 upon 4n plus 1 pi. 1 upon x and x की जगह दोनों जगह xn रखा गया. This will become this 4n plus 1 pi upon 2 and sine of 4n plus 1 pi upon 2. अब आप सोच रहे होंगे मैंने क्यों सेलेक्ट किया. The reason is that 5/2 पे साइन क्या होता है? 1। और 4n+1 से क्या नंबर्स बनेंगे? n=0 लूँ तो 5, 1, n=1 लूँ तो 5, तो 5/2 हो, 9π/2 हो, 13π/2 हो, यानी डोमेन सीक्वेंस जो मैंने ली है उस डोमेन सीक्वेंस का रेसिप्रोकल जो है दैट गिव्स मी ऑड मल्टीपल्स ऑफ π/2। π/2 पे साइन 0 है, हर ऑड मल्टीपल ऑफ π/2, सॉरी, π/2 पे साइन 1 है और हर ऑड मल्टीपल ऑफ π/2 पर साइन की वैल्यू 1 है। सो एज दिस डिनोमिनेटर x और दिस थिंग गोज टू इंफिनिटी, हमारे पास जो रिजल्ट आ रहा है इंफिनिटी इंटू 1 आ रहा है, एंड इंफिनिटी इंटू 1 आने का मतलब है इंफिनिटी। अच्छा जी, I hope this is sensible, क्योंकि ओरिजिनल फंक्शन में as x approaches infinity 1 upon x, x approaches 0, 1 upon x goes to infinity, and when x is very large साइन की वैल्यूज का हमें कुछ पता नहीं है, -1 से 1 के दरमियान कुछ भी हो सकती है। अब हमने एक ऐसी स्कीम डिजाइन की थ्रू सीक्वेंस इन डोमेन कि साइन की वैल्यूज जो हैं वो 1 आए। चलो भाई, ये एक अप्रोच हो गई एक सीक्वेंस से। लेट अस मेक अनदर सीक्वेंस and that sequence terms are 1 upon n pi. So 1 upon x becomes n pi and sine of 1 upon x becomes sine of n pi. Now, what happens? When you consider n, 1, 2, 3, 4, 5, what are the values of sine n pi? Sine pi 0 है, sine का हर multiple 0 है. So before you go to infinity, you find that sine n pi is always 0. When this is always 0, आप इस 0 को किसी भी multiply करें, it will remain 0. So using one sequence, we got the limit infinity. Using another sequence, we got the limit 0. And that proves that this does not exist. This limit does not exist. So using sequential approach, we can use in the domain sequences that approach to C. C यहाँ पे 0 है, अगर C 0 ना होता तो हम यहाँ पे सीक्वेंस कुछ और बनाने की कोशिश करते हैं। Of course, working out with sequences, limit निकालना आसान हो जाता है, but how to use a sequence is definitely a tricky job.
सर ये साइन की वैल्यू 1 वाला जरा दोबारा करा दें।
Okay, xn was taken 2 upon this. So reciprocal becomes 4n plus 1 by 2 of pi. मैंने यहाँ पे ये बताया कि n कुछ भी हो, चाहे इन्फिनिटी हो चाहे फाइनाइट हो, साइन की वैल्यूज n से बन रही हैं। n is equal to 1 gives you what? This number 5 multiplied by pi/2. So 5 pi/2, then 9 pi/2, then 13 pi/2, then 17 pi/2, then 21 pi/2. ये जो सीक्वेंस की टर्म्स बन रही हैं इस पर साइन हमेशा 1 रहता है। तो इसका मतलब है साइन सीक्वेंस जो बनी है, ये जो सीक्वेंस बन रही है इसकी हर टर्म 1 है। So as n approaches infinity, this will remain 1. So when you apply n approaches infinity on the sine function, that limit will be 1. Whereas ये जो साइन के बाहर जो सीक्वेंस है, as n approaches infinity, that goes to infinity. So infinity into 1 is definitely infinity. So sine series जो बनी corresponding to sine sequence जो बनी corresponding to this sequence in the domain, उसकी हर टर्म 1 है। हमने ये चूज इस तरह से किया है कि मल्टीपल ऑफ pi/2 आए। और कौन से मल्टीपल ऑफ pi/2 आए? देखो pi/2 पे साइन 1 है, 3 pi/2 पे साइन -1 है, लिहाजा हमने सारे ऑड मल्टीपल्स नहीं बनाए। पाई बाई टू पे 1 है, उसके बाद 5 पाई बाई टू पे 1 है, यानी पाई बाई टू प्लस 2 पाई। तो दैट इज व्हाट इज एडेड। पाई बाई टू में 2 पाई ऐड करते चले जा रहे हैं, तो 5 पाई बाई टू, 9 पाई बाई टू, 13 पाई बाई टू, जिससे ये जो साइन सीक्वेंस बनी इसकी हर टर्म 1 1 1 1 1 चली आ रही है। दैट इज वाई एज एन अप्रोच इंफिनिटी दिस गोज टू 1। और इस फैक्ट को इस्तेमाल करके हमने इसकी लिमिट लिखी। जो आउटसाइड टर्म है दैट इज गोइंग टू इंफिनिटी एज एन अप्रोच इंफिनिटी, बट साइन टर्म, साइन फैक्टर जो है दैट इज गोइंग टू 1। So infinity into 1 is infinity, and the limit of this function as x approaches 0 through this sequence is infinity, whereas through this sequence it is 0. So to produce alternate ways of getting different limits as x approaches c, we are using now different sequences in the domain that approach to the same c, चाहे ये हो चाहे ये हो। n approaches infinity, so xn goes to 0, xn goes to 0। तो हम ऐसी कई सीक्वेंसेस बना सकते हैं जो विद इन द नेबरहुड ऑफ पॉइंट सी हो और कन्वर्ज कर रही हो सी पे। दिस इज वन एग्जांपल ऑफ दैट। दिस इज अनदर एग्जांपल। Function given is x square signum cos x. Do you remember signum function? Wait, anybody remember signum function?
No, sir.
Arey wow. This takes value 1 for each x positive. इसका कलर चेंज करूँगा, कहाँ से होगा? And it takes on value -1 for each x negative. And its graph is something like this. Not touching here goes to right side, not touching here goes to left side. And some people define कि भाई ये 0 पे डिफाइन नहीं है, तो भले से ना हो 0 पे डिफाइन, लेकिन अगर आप 0 पे डिफाइन करना चाहते हैं तो लोग कहते हैं इसकी वैल्यू 0 है when x is equal to 0. It doesn't make any difference. अच्छा साहब, now cos can be positive, can be negative. When x is very, very large, we will keep on getting positive and negative values of cos from -1 to 1. If the cos value is positive, then signum will be +1. If cos value is negative, signum will be -1. So इसका मतलब है signum जो है, हाँ, signum function एक और तरह से भी डिफाइन किया जाता है, mod x upon x। और जाहिर है कि ये x is equal to 0 पे डिफाइन नहीं है। When x is positive, this is 1. When x is negative, this is -1. So cos को जब हम signum का आर्गुमेंट बना देंगे तो इसके आउटपुट +1 और -1 आएंगे, right? Okay. What is outside? Outside is x square. मुझे इसकी लिमिट निकालनी है। When x is very, very large, this goes to infinity, but this remains either +1 or -1. So that gives me a variety कि ये negative infinity होगा या positive infinity होगा। Instead of going that old classical approach, जिसको मैं delta approach से नहीं कर सकता, x is going to infinity, I have to see whether when x is very, very large, what happens to this. उसके लिए मैंने सीक्वेंस ली -2 pi n. As x approaches, अच्छा क्वेश्चन में -infinity था. As x approaches -infinity, of course n approaches infinity, and I use this in this function. So cos of -2 n pi. अब देखो जो मैंने सीक्वेंस बनाई है, cos 0 1 होगा, cos -2 pi 1 होगा, cos -4 pi 1 होगा, cos माइनस, तो एक ऐसी सीक्वेंस बना दी में कॉस की वैल्यू हमेशा 1 होगी। जब कॉस की वैल्यू हमेशा 1 होगी तो सिग्नम ऑफ 1 विल बी 1, whereas this turns out to be x square 4 pi and 4 pi square n square, ये pi square होगा। This goes to infinity as n approaches infinity और x approaches minus infinity। इसका मतलब ये हुआ कि हमारे पास जो लिमिट आ रही है, हमने फंक्शन इस, लेट मी कॉल राइट इट एज fx, so this goes to infinity, fx approaches infinity। अच्छा साहब, पहले मैंने सीक्वेंस बनाई थी -2 πn, अब मैं सीक्वेंस बना रहा हूँ -2 π + 1n। अच्छा, इससे क्या होगा? अगर मैं x इज इक्वल टू, इसमें n किधर गया भाई? n तो लिखा ही नहीं मैंने, देयर शुड बी n, सो देयर शुड बी n इन्वॉल्व हियर, एंड हियर मैंने n लिखा हुआ है। अच्छा, अगर n इज इक्वल टू 0 हो तो cos 0 1 होगा, n 0 है तो ये where should n appear? I have not written n in the appropriate place. ये तो पिछली लिमिट थी। 2 πn यहाँ आना चाहिए, 2 πn यहाँ आना चाहिए, 2 πn यहाँ आना चाहिए। So I'm working with cos of minus of 2n pi plus 1 2n plus 1 pi। अच्छा जी, n इज इक्वल टू 0 माइनस पाई आया, n इज इक्वल टू 0 के लिए माइनस पाई आया। So what's the value of cos when n is minus pi, argument is minus pi? इधर cos 0 1 होता है, cos minus pi जो है वो -1 होता है। n इज इक्वल टू 2 लूँ तो क्या आएगा? -5 pi। What shall be -5 pi? -pi से उल्टा 2 पाई घूम के फिर मैं वहीं आ गया तो -1 होगा। n इज इक्वल टू 2 लिया था, 7 ले लो, तो 14 15 -15 pi। So how many rotations are there in 15 pi? 7 rotations are there indicated by this n and minus pi, and this will be, so अब के मैंने ऐसी सीक्वेंस बनाई है जिसमें cos की वैल्यूज हमेशा -1 आए और सिग्नम की वैल्यू अकॉर्डिंगली, for negative x signum is always -1, so cos signum of cos x will be -1, and the outside यहाँ भी जो है ये this is not correct, it's 2n plus 1 pi square, okay। तो ये इन्फिनिटी को जा रहा है और ये -1 जा रहा है, so that means it's going to negative infinity। पिछली दफा it is going to positive infinity, now it is going to negative infinity। तो वो जो हमारा कंफ्यूजन था कि ये पॉजिटिव इन्फिनिटी को जाएगा या नेगेटिव इन्फिनिटी को जाएगा, उस कंफ्यूजन को हमने दूर किया दो सीक्वेंसेस लेके। एक सीक्वेंस लेने से एज एक्स अप्रोचेस इन्फिनिटी हमारा रिजल्ट आया कि फंक्शन अप्रोचेस इन्फिनिटी, जबकि एक और सीक्वेंस लेने से पता चला कि दिस सीक्वेंस गोज टू नेगेटिव इन्फिनिटी ऑल्सो। तो एक सीक्वेंस से पॉजिटिव इन्फिनिटी लिमिट आ रही है फंक्शन की और एक सीक्वेंस से नेगेटिव इन्फिनिटी आ रही है। So this is a big advantage of using sequences in obtaining limits of functions. Sequences in the domain which make sequences in the range, और हम limit as n approaches infinity निकालते हैं because the sequence in the domain that we are considering, whatever the sequence we are considering, that approaches c, so हम हमेशा ऐसी सीक्वेंसेस बनाएंगे जो उस पॉइंट पर कन्वर्ज कर रही हो, जो कि जिस पे पॉइंट पे कि हम लिमिट ले रहे हैं, चाहे वो 0 हो, चाहे वो इन्फिनिटी हो, चाहे वो कुछ भी। सो लेफ्ट हैंड एंड राइट हैंड अप्रोचेस जहाँ काम नहीं कर रही, जहाँ कोई और अप्रोच काम नहीं कर रही, वहाँ दूध का दूध पानी का पानी करने के लिए, यानी डिफरेंट लिमिट्स हासिल करने के लिए, सो दैट वी कैन शो दैट लिमिट डज नॉट एग्जिस्ट, हमने ये सीक्वेंशियल अप्रोच इस्तेमाल। I know things are tricky, things are, but this is in fact one thing that you have learned out of last half hour's discussion as something new. जो मिस्टेक्स हैं इसमें जो मैंने शो की थी वो मैं करेक्ट कर दूंगा ओरिजिनल फाइल में, एंड आई होप यू कैन डू दैट योरसेल्फ. Okay. Continuous functions, that you are familiar with the idea of continuity, that limit and the value of the function are same, then the function is continuous. Left hand limit, right hand limit is equal to value of the function. Or for every epsilon, there is delta, such that limit has been replaced by the function value. That images are close to the image FC whenever pre-images are close to C. So left hand side, left hand continuity, right hand side, right continuity. If the function is both left continuous and right continuous, then the function is continuous. What are the things that produce discontinuities? Or we say that different types of discontinuities. You can number them in any form, but when you solve problems, we come to see that we can identify whenever there is a discontinuity, then whether it is removable discontinuity, where limit exists, but is not, a value exists, but they are not same. Left and right limits both exist, but are not equal. Left limit exists and is not equal to the function value. A right limit exists, but is not equal to the function value. Neither left limit nor right limit exists. Function value exists or not. We talk about left continuous if left limit is same as the function value. We say right continuous or connected from right if the right limit is same as the function value. So we will come across different situations when two functions are continuous. Their sum and differences will be continuous. Their product will be continuous. Their quotient will be continuous if the denominator limit is not zero. And these are classical proofs, and you can find them in any elementary book. अब यही फंक्शन जिसका हमने पहले प्रूव किया था, लिमिट डज नॉट एग्जिस्ट. तो now we are showing that अगर मैं x is equal to 0 पे इस फंक्शन को इस तरह से डिफाइन कर लूँ, तो चूँकि लेफ्ट हैंड लिमिट और राइट हैंड लिमिट डिफरेंट आ रही हैं, so we say that the function is different नहीं आ रही यार, ये सेम आ रही है, सॉरी. x की वजह से. So left hand limit 0 minus delta. So as delta approaches 0, 1 upon delta approaches infinity, e raised to power 1 upon delta approaches infinity, whereas e raised to power minus 1 upon delta approaches 0. So 0 into 0 divided by 1 plus 0 is 0. प्रॉब्लम जब होती है जब न्यूमरेटर और डिनोमिनेटर दोनों 0 आ जाएं, लेकिन ऐसा नहीं हो रहा, लिहाजा लिमिट 0 आ रही, लेफ्ट हैंड लिमिट. So the same logic used in a slightly different way, because as delta approaches 0, 1 upon delta is infinity, so numerator में infinity आ रहा है. उस infinity को से बचने के लिए आप इसका expansion इस्तेमाल करें. इसका एक्सपेंशन इस्तेमाल करेंगे तो इनफैक्ट ये जो एक्सपेंशन है जी, ये कौन सा एक्सपेंशन है? थोड़ी देर पहले मैंने आपको बताया था कि e power x is equal to 1 plus 1 upon x plus 1 upon 2x square plus so on. So अगर आप e power 1 upon delta के expansion लिखेंगे तो that will be 1 plus x की जगह 1 upon delta plus 2x square की जगह 1 upon 2 क्या कर दिया मैंने लाहौल वाला e power x is 1 plus x square upon 2 factorial. इसका ये बटन दब जाता है तो मसला हो जाता है. Sorry, yeah, it's gone out of my control. Without putting it on the notepad, it's writing. तो इसके अंदर अगर मैं एक्सपेंशन रखता हूँ 1 plus 1 upon डेल्टा, तो 1 plus 1 upon डेल्टा की वजह से एक डेल्टा आएगा और बाकी सारी टर्म्स जो हैं दैट विल बी लार्ज. So large taken common from both numerator and denominator, and ये वर्किंग जो है मैंने थोड़ा सा रफली की हुई है, बट दिस लिमिट कम्स आउट टू बी 0. ये जो एक्सपेंशन वाली अप्रोच हमने पहले इस्तेमाल की थी वो इस्तेमाल करें. डिटेल के साथ मैंने रफली इस्तेमाल की है, बट लिमिट कम्स आउट टू बी 0. द फंक्शन वैल्यू इज डिफाइंड टू बी 0. So the function is continuous. Classical example, and I'm not discussing this. Not discussing this as well. Not हाँ, यहाँ बता दूँ कि ये mod x है जबकि ये bracket x है. And what was bracket x? I hope some of you remember. Not the whole function is being used here. This bracket x function, it takes on values like this when x is 0 to 1, takes on value 2 when x is 1 to 2, 1 inclusive, 2 not inclusive, minus 1 when minus 1 inclusive, 0 not inclusive, और इसका जो ग्राफ बनता है वो समथिंग लाइक स्टेयर्स, जंप जंप, याद आया ऐसा कोई फंक्शन कैलकुलस में पढ़ा था? हेलो
जी सर.
हाँ, तो ये वो ब्रैकेट फंक्शन है और यहाँ पर हम इसकी कंटिन्यूटी डिस्कस कर रहे हैं x इक्वल टू 3 पे. So x इक्वल टू 3 पे it jumps to x इक्वल टू 2 पे it jumps to 2, x इक्वल टू 3 पे it jumps to 3. So f of 3 is 3 minus 3, which is 0. Whereas left hand limit लेंगे तो 3 minus delta or bracket 3 minus delta. So just to the left of 1, 2, 3, just to the left of 3, this will give you 2. So 3 minus delta minus 2 is 1 minus delta, which will be 1. Whereas the right hand limit के लिए 3 plus delta, तो 3 plus delta पे जो jump कर चुका होगा, so that will give you 3, and 3 plus delta minus 3 gives you limit 0. So in this way, हाँ, ये जो अगली एग्जाम्पल आ रही है, that is an interesting example, and Dirichlet function, as it is known, when x, now this function is defined for all real numbers. When x is rational, the image is 1. When x is irrational, the image is minus 1. So if you'd like to make a graph of this function, there will be points on the graph at a height of 1 throughout, but with gaps. Because for rational, it will be plus 1. And for irrational, there will be a horizontal line with gaps at the depth of minus 1. And this function is not continuous anywhere. So, there is someone asking question. No? Okay. Here I have taken a rational number. When input is rational, the output is 1. And then I consider a series of irrational numbers. For all irrational series n, and a series of irrational numbers, I can assume converges to A. A is rational, so fa is 1. I consider series of irrational numbers. Series is, in fact, this is not series, this is a sequence. Sequence of irrational numbers that converge to A. That means इस sequence की limit A है, so any irrational number that comes from the sequence minus the limit will be less than epsilon, which I can take as 1 upon n for all n. As n becomes larger and larger, this statement says that an is coming closer and closer to A. Achha. If I'm trying to find limit x approaches A, where A is a rational number of function f, in fact, I'm trying to find the limit n approaches infinity of an. Now, for every irrational number, this sequence an, the image will be what? Every an is irrational. So every image will be minus 1. So when n approaches infinity, I will have images minus 1. Remember, लिमिट निकालते वक्त हम ये नहीं देखते कि जिस पॉइंट पे हम लिमिट निकाल रहे हैं उस पॉइंट पे फंक्शन वैल्यू क्या है, बल्कि हम ये देखते हैं कि उस पॉइंट के नेबरहुड में फंक्शन वैल्यू क्या है. और नेबरहुड में जो हमने पॉइंट्स लिए हुए हैं वो अकॉर्डिंग टू सीक्वेंस ऑफ इरेशनल नंबर्स लिए हुए हैं. तो whenever the main point is an irrational point, the function will be minus 1. So image sequence is always having term minus 1, minus 1, minus 1 for every irrational number, and whether it converges to a rational number, it is always possible, because everywhere there are infinitely many rationals and infinitely many irrationals that we have proved somewhere in the first or second chapter. So the image sequence always have term -1. That means the limit of the function as x approaches a, where a is rational, लेकिन हमारे पास चूंकि सीक्वेंस irrational numbers की है तो आउटपुट जो है वो हमेशा -1 है. So limit is not same. Limit is not same as the value of the function. A is rational, so its value is 1, but the sequence of irrational numbers produces this limit to be not equal to 1, rather it is -1. That proves that this function is not continuous anywhere because A is any rational number. और अगर मैं A को irrational ले लूँ तो सीरीज सीक्वेंस जो कंसीडर करूँगा वो rationals की कंसीडर करूँगा and will arrive at the same result. This is a similar question. I hope you can explore it yourself. जब x irrational है तो आउटपुट वही irrational हो. जब x rational है तो आउटपुट नेगेटिव ऑफ दैट rational हो. इसकी कंटिन्यूटी डिस्कस कर रहे हैं हम x इक्वल 0 पे, और ये अक्सर और ये भी कह रहे हैं कि उसके अलावा कहीं कंटिन्यूस नहीं. f0 is 0 because 0 is rational. So f(x is equal to -x) से f0 0 आ गया. और लिमिट एज x approaches 0. अब मैं जो सीक्वेंस कंसीडर करूं जो 0 पे कन्वर्ट कर रही है, वो रैशनल्स की हो या इरेशनल्स की हो, वो 0 पे ही कन्वर्ट कर रही है. तो वैल्यू ऑफ द फंक्शन एंड लिमिट ऑफ द फंक्शन आर सेम, so the function is continuous at x is equal to 0. But if we consider continuity at a point which is not 0, which is some number a, तो फिर वही है कि a को रैशनल ले लूँ और सीक्वेंस लूँ, a को इरेशनल ले लूँ और सीक्वेंस लूँ रैशनल से, and then I'll find that के जो वैल्यू है, चूँकि a को हमने इरेशनल लिया हुआ है तो आउटपुट विल बी सेम एज a इरेशनल, और सीक्वेंस जो है वो रैशनल में से ली हुई है, कन्वर्ज कर रही है वो a पे, लेकिन सीक्वेंस की टर्म्स पे जो इमेज सीक्वेंस बनेगी वो हमेशा क्या बनेगी, क्योंकि इमेज सीक्वेंस बन रही है उन फ्री इमेजेस से जो कि व्हाट रैशनल्स हैं. तो रैशनल्स पे हमेशा नेगेटिव होगा, तो नेगेटिव a आएगा रिजल्ट. सो लिमिट एज x approaches a is -a, which is not equal to the function value which is a. तो जब भी इस तरह की सिचुएशन आएगी हमारे पास, तो हम लिमिट किसी पॉइंट पर निकालने के लिए अगर पॉइंट को हम जिस पर लिमिट निकाल रहे हैं वो इरेशनल है तो वो फंक्शन वैल्यू उसके हिसाब से आएगी, और सीक्वेंस बनाएंगे रैशनल्स की, या अगर a को हम रैशनल ले लें तो फंक्शन वैल्यू आएगी उसके हिसाब से, और उसके बाद सीक्वेंस बना लें इरेशनल्स की, और इरेशनल्स पे हमारे पास इमेजेस डिफरेंट है, लिहाजा लिमिट डिफरेंट आएगी. So nowhere it can be continuous. Now what kind of graph this function will have can be shown. Let me try to use the whiteboard again. The function under question, ये क्या सब नीचे उतारा? What I'm talking about is this: f(x is equal to x) for each x belonging to the rational numbers. वहाँ पे वैसे irrational था वो. For now, rationals and irrationals are spread here. So y is equal to x will be something like this: images of all rational numbers on the x-axis, whereas all irrational numbers on the x-axis, the images are negative. Y is equal to -x. So that will be something like this. Or if I change the color, so that means I'm talking about what? This represents the graph of y is equal to x, dotted graph because it is giving images only for rational numbers, and this one is y is equal to minus x. Again dotted graph, red one, because only irrational numbers की images जो हैं वो red line पे आ रही हैं. So you can feel that there are lots of things that can be done that were not done at the elementary level. This is exercise on page 172-73, and I have solved almost all the questions. आप इनको देखिए और अगर समझ में ना आए तो you can send me a query and we can discuss that. Let me go to कौन सी वाली एक्सरसाइज है? ओके, लिमिट एंड कंटिन्यूटी की एक्सरसाइज है ये. व्हाट इज दिस? This is what I was discussing. Sequence approach. Before I terminate my discussion today, हमने आज जो सबसे अहम चीज़ सीखी है, चाहे मैं लिमिट निकाल रहा हूँ, चाहे मैं कंटिन्यूटी डिस्कस कर रहा हूँ. When I discuss continuity, मैं लिमिट डिस्कस कर रहा हूँ. When I am not concerned about continuity, मैं सिर्फ लिमिट डिस्कस कर रहा हूँ. When लिमिट डिस्कस कर रहा हूँ तो जिस पॉइंट पर लिमिट निकाल रहा हूँ उस पॉइंट पर फंक्शन डिफाइन है या ना डिफाइन है, इससे मुझे कोई गलत. First, let us see this on page. The continuity on a closed interval. नहीं, सही है यही है. There are 4. Sequential approach, the advantage. A function f is defined on an interval I, is continuous at a point c belongs to I, if and only if every sequence, that means x values से बनी हुई sequence, in the interval I converge to C, we have limit n approaches infinity of the images of the sequence, every sequence that converges to C, the limit of the images of the sequence is FC. Now, what's the message of the theorem? The message of the theorem is that कि मैंने एक फंक्शन कंसीडर किया जो कि किसी इंटरवल पे डिफाइन. ऑफ कोर्स इंटरवल जब हम बात कर रहे हैं तो आई लिख रहे हैं, लेकिन वी आर मोर यूज्ड टू विद आई इन द फॉर्म ऑफ ए बी. Now this may be a closed interval or this may be an open interval, but what we are taking, we are considering C to be some point in I. ये तो बात हो गई इंटरवल की. अब इस पॉइंट पर फंक्शन कंटिन्यूअस किस सूरत में होगा? If and only if हर सीक्वेंस that I can make within I that converges to C, the limit n approaches infinity of the image sequence is FC. तो इंटरवल के बाद इंपॉर्टेंट क्या है? उस इंटरवल में जो भी सीक्वेंस बनाऊं मैं जो सी पे कन्वर्ज कर रही है और उस सीक्वेंस को इस्तेमाल करूं फंक्शन की लिमिट निकालने के लिए, एट सी मीन्स दैट आई एम टेकिंग द sequence converges to C, so I am taking the image sequence and trying to find its limit, and that limit has to be FC, the value of the function here. So that is a replacement of the idea of, basic idea of limit x approaches C of fx is equal to fc. तो थ्योरम का असल मैसेज ये है कि इस इंटरवल में ऐसी तमाम सीक्वेंसेस जो सी पे कन्वर्ज कर रही हों उनकी इमेज सीक्वेंसेस बनाऊं और उनमें से हर इमेज सीक्वेंस जो है वो FC पे कन्वर्ट हो, तो फंक्शन कंटिन्यूस होगा। अगर ऐसा होगा तो फंक्शन कंटिन्यूस होगा, और कंटिन्यूस फंक्शन कंटिन्यूस होगा तो ये सब कुछ ट्रू होगा। A proof is described. Let f be continuous at x equal to c, and a sequence is there in I. That means every term of the sequence belongs to the interval that we are talking about, and that sequence converges to C, where we are discussing the continuity. As f is continuous C, for every epsilon greater than 0, there is a delta greater than 0 such that fx minus fc is less than epsilon whenever x belongs to the radiated neighborhood of C. Also, हमें ये hypothesis ये कह रहा है कि there is a sequence whose limit is C. Sequence जिसकी हर term interval I में है. Now, sequence convergence means for every epsilon की जगह delta इस्तेमाल किया मैंने इस दफा, there exists a positive integer such that all terms of the sequence are within the neighborhood of C after first few terms. अच्छा जनाब, अब सेकंड में x माइनस सी लेस देन डेल्टा है, अब x की जगह Cn रख दो, points which are elements of the interval as well as members of the sequence. तो अब 1 हो जाएगा f x की जगह Cn minus fc is less than epsilon whenever Cn minus c is less than delta. And 2 means that in fact this holds when this holds, and when this holds for all n except for the first few terms. So बीच में से Cn minus c less than delta निकाल दो, so this directly is under this condition. What? Fcn minus fc is less than epsilon for every n greater than 0, and that means the image sequence converges to fc, and that means the limit of the image sequence is fc, or the limit of the function is fc, as this thing is equivalent to limit fx approaches fc as x approaches c. So this new dimension today that has been introduced is very important, very interesting. Choice of the sequence should be such that every element of the sequence is in the interval. That interval contains C. This choice is free. Every sequence, as long as that sequence converges to C, which is a point in I. This provides infinitely many choices to approach to x is equal to C, not only left-hand limit, right-hand limit. So we have opened our path, open our scope to infinitely many paths, even for function of one variable. आपने कैल 2 कैल 3 में पढ़ा होगा कि जब तुम फंक्शन ऑफ 2 वेरिएबल्स निकाल कंसीडर करते हो, तो फिर जनाब एक्स वाई कैन अप्रोच टू ए बी फ्रॉम इन्फिनिटली मैनी पाथ्स, अप फ्रॉम डाउनवर्ड, अपवर्ड, राइटवर्ड, लेफ्टवर्ड, through y is equal to x, through y is equal to x square, and blah 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 blah. अब हमने यहाँ वही सूरत हाल कर दी कि फंक्शन ऑफ वन वेरिएबल के केस में भी we have got infinitely many choices to approach x is equal to c, not only the left hand. जो सीक्वेंसेस होंगी वो जरूरी नहीं है कि सिर्फ लेफ्ट हैंड पे उसकी टर्म्स हो, जरूरी नहीं है कि सिर्फ राइट हैंड पे टर्म हो. सीक्वेंस की टर्म्स जो हैं वो सी के इर्द गिर्द कहीं भी फैली होंगी. एल माइनस एक्स, सी माइनस डेल्टा से सी प्लस डेल्टा के दरमियान सीक्वेंस की टर्म्स होंगी. Now if f is not continuous at x is equal to c, इसका मतलब fx minus fc will be greater than epsilon. That means image values will not be close to fc. That means limit of the function is not equal to fc. अच्छा, या इस सूरत में मैं whenever x is close to c, fx is not necessarily close to x. अगर मैं डेल्टा की जगह 1/n ले लूँ, for every n there is a cn in the interval such that fcn minus fc is greater than 0 whenever cn is close to c. So cn converge कर रही है c पे, but image sequence is not converging to fc. This is an expression of discontinuity of a function in terms of sequence. So that is a very strong idea, more sophisticated an idea as just the idea of limit a function of one variable that we studied at an earlier stage. मैं थोड़ा आज 10 मिनट पहले ख़त्म करूँगा, जो मुझे नेक्स्ट आर्टिकल शुरू करना है. In fact, I have to launch into analysis of functions with this new and more sophisticated manner. And the first theorem that I want you to get familiar with is about that अगर मेरे पास एक फंक्शन है जो कि किसी इंटरवल पे, क्लोज इंटरवल पे कंटिन्यूस है, तो फंक्शन विल बी बाउंडेड. ऐसी थ्योरम का जिक्र तुमने सुना होगा, शायद अगर किसी ने रोल्स थ्योरम प्रूव कराई हो तो उसका जिक्र किया होगा. अगर नहीं किया होगा तो कोई मसला नहीं, वी विल स्टार्ट इट एज न्यू and I will start my discussion from this theorem next time. With that, I stop my discussion today. And first, I stop the recording.